A linen shroud tested by 3 world-class labs in 1988 should have closed the case forever. Its medieval date was declared, and the debate was over. Yet the more scientists peel back its layers, from contradictory carbon tests to elusive blood and three-dimensional data, the less the mystery yields. Today, even the most advanced AI tools cannot untangle how the image was made. So why do so many hard facts only deepen the doubt, leaving the world's most scrutinized relic unexplained? The first cracks began not with ancient legend, but with an official scientific verdict. On the morning of April 21, 1988, a single strip of linen, measuring 81 millimeters long and just 16 millimeters wide, was cut from the shroud's lower corner. This sliver, barely the size of a bandage, became the entire basis for the most influential dating test in religious history. Under the watchful eyes of church officials, textile experts, and British Museum representatives, the strip was divided and sealed for 3 laboratories: Oxford, Zurich, and Arizona. Each lab received only a fraction of the original, alongside control samples of ancient linen. The process, meant to guarantee fairness, instead planted seeds of doubt. The British Museum managed the chain of custody, certifying each transfer and recording every step. Yet the chosen corner had a known history of exposure and possible repairs following the fire of 1532. No other part of the cloth was sampled. Critics later pointed out that this area might not reflect the age of the entire shroud, especially if medieval threads or contaminants were present from restoration work. When the results arrived, the numbers seemed to agree. All 3 labs dated their samples to between 1260 and 1390 AD, a medieval window. The British Museum's summary declared the results statistically compatible, but the raw data, released years later, told a different story. The spread between labs was wider than expected. Zurich's mean date was 676 years before present, Oxford's was 750, and Arizona's was 646. Statisticians ran chi-squared tests and found the variation significant. The p-values were below 0.05, which means the results should not be treated as a single, unified age. The data's heterogeneity called the entire sampling process into question. The controversy deepened as researchers examined the sample's provenance and the statistical inconsistencies. The physical removal of just one strip from one corner left open the possibility that the sample was not representative of the whole. With each challenge, the certainty of a medieval date faded. The debate over the shroud's true age reignited. It was no longer just about faith, but about the reliability of science itself. Ray Rogers, a chemist from the original STURP team, approached the shroud's dating controversy with a different set of tools. Instead of relying on radiocarbon numbers, he turned to the chemistry of linen fibers themselves. Rogers focused on vanillin, a compound that slowly vanishes from cellulose as centuries pass. In medieval linens, vanillin lingers, its presence detectable in the yellowed threads. But in ancient textiles, the compound is long gone, broken down by time and heat. Rogers obtained thread samples from the same corner used in the 1988 accelerator mass spectrometry test, along with fibers from the main body of the shroud. He also gathered control samples, medieval church linens, and ancient Egyptian cloths. Under the microscope, he applied chemical tests for vanillin. The results were clear. The radiocarbon sample area showed faint traces of vanillin, but the main body of the shroud had none, matching the profile of linens over 1,300 years old. Medieval repair threads, woven into the corner after the 1532 fire, still retained vanillin. Rogers concluded that the radiocarbon sample was a patchwork, a blend of old linen and newer cotton, skillfully rewoven to repair fire damage. The chemistry suggested that the tested corner did not reflect the age of the original cloth at all. The implications were stark. If vanillin loss points to an age far older than the radiocarbon date, then the shroud's true history remains unresolved. Rogers' findings, published in 2005, did not overturn the accelerator mass spectrometry results, but they forced scientists to reconsider the foundation of those tests. The shroud's fibers, exposed to centuries of heat, smoke, and restoration, had become a puzzle of mixed ages. Chemical markers like vanillin offered a silent record of time's passage, one that could not be faked or erased by medieval hands. For many, this chemical evidence reopened the debate, hinting that the shroud's secret might still be hidden within its tangled threads. Under the microscope, the shroud's linen fibers reveal a puzzle no artist has solved. The faint image, so striking to the naked eye, vanishes when examined up close. There are no brushstrokes, no pooling of pigment, and no trace of any paint binder, just a subtle yellowing on the very tips of the outermost fibers. Scientific teams, including the Shroud of Turin research project in 1978, scoured the surface for evidence of artistic technique. They found none. Instead, the image rests within a layer 200 nanometers deep, less than 1,000th the width of a human hair. This ultra-shallow discoloration is not absorbed into the threads, but clings to the surface, as if the linen itself had been lightly scorched by something unknown. John Jackson, a physicist and the team leader for the Shroud of Turin research project, described the findings. He said the image contains three-dimensional information that is impossible for medieval artists. His team ran dozens of chemical and spectroscopic tests, searching for any trace of pigment, dye, or stain. None appeared. Even under ultraviolet fluorescence, the image areas did not behave like paint or organic stains. Where artists would have used glue or egg to bind pigment, the shroud's fibers are bare. No particles, no residue, just the linen itself. Attempts to recreate the image with known medieval methods failed. Paints, powders, and even hot bas-reliefs all left telltale signs: pigment grains wedged between fibers, color bleeding into the weave, or damage far deeper than the shroud's delicate surface change. In every experiment, the result was either too deep, too crude, or easily detected under magnification. The shroud's image, by contrast, is so superficial that even gentle rubbing can remove it from the cloth. This microscopic evidence has forced scientists to rule out the classic forgery scenario. The absence of any pigment particles or binding agents, combined with the impossibly shallow discoloration, means that no known artistic technique, ancient or modern, can account for the image. The question remains, if not paint, what process could have left such a precise, ghostly imprint, visible at a distance, but nearly invisible up close? The search for answers would soon turn to the bloodstains, and the story they tell about the sequence of events locked within the linen's weave. Bloodstains on the shroud do not behave like artistic flourishes or staged effects. They follow the laws of biology and physics, mapping a story of trauma in real time. Forensic tests confirm the stains are human blood, type AB, rare but not unknown in the Middle East. Hemoglobin and serum albumin penetrate deep into the linen, soaking through the weave in a way that paint or dye never could. Under ultraviolet light, the blood fluoresces with the signature of real hematic material, not the dull glow of iron oxide pigment. The sequence of events is written in the cloth. Blood was absorbed into the fibers before any body image formed. In every case, the image itself stops at the edge of a stain, as if whatever process scorched the linen respected the boundaries of the blood. This order, blood first, image second, defies the logic of forgery. Medieval artists, even the most skilled, would have had to predict the exact placement of each wound, then paint around them with a precision invisible to the naked eye. No known technique from the period comes close to this result. The scientific team that gathered in Turin in 1978 was not united by these discoveries. John Jackson, a physicist, and Walter Macrone, a chemist, clashed over every detail. Jackson's group, relying on spectroscopic and microscopic data, insisted the stains were genuine and the image unreplicable. Macrone, skeptical from the start, argued for a more mundane explanation: traces of iron oxide perhaps, or artists' trickery. Late-night arguments stretched on for hours, with lab notebooks filling up with rival theories. But as the evidence mounted, real blood, no pigment, no binder, Macrone's position grew isolated. The data, peer-reviewed and published, left little room for compromise. The wounds themselves tell their own story. Trickling flows from wrists and feet, a 2-inch side wound, and a lattice of scourge marks across the back. Forensic pathologists mapped these as consistent with Roman crucifixion, not the stylized, bloodless wounds of medieval art. Each stain, each angle, matches the way blood would run from a suspended body, not a painted canvas. Within the team, these findings did not settle the debate, they only deepened the rift. The shroud's blood evidence, so precise and so real, defied both artistic explanation and easy scientific answers. As tensions flared among the experts, New voices called for advanced technology to break the impasse, hoping that modern tools might finally explain what centuries of argument could not. Liberato De Caro, a physicist at Italy's Institute of Crystallography, set out to answer a question that had haunted the Shroud's history for decades. Could modern technology, free from the pitfalls of old sampling and contamination, reveal the true age of the linen? In 2022, De Caro's team turned to wide-angle X-ray scattering, spelled WAXS. It is a method that reads the molecular structure of flax fibers like a time capsule. Instead of burning or dissolving the cloth, WAXS fires X-rays through a single thread less than a millimeter wide, measuring how the cellulose chains inside have broken down over centuries. Each linen sample, whether from ancient Egypt or medieval Europe, produces a unique scattering pattern, a molecular fingerprint of age. De Caro's team compared a shroud fiber with dated controls, including a fragment from Masada in Israel, woven around the time of the 1st century. The result was striking. The shroud's X-ray signature matched the Masada linen, not the younger medieval samples. The data pointed to an age of roughly 2,000 years. According to De Caro, the shroud's cellulose had degraded in a way that would require either millennia of natural aging or an impossible amount of heat and humidity if it were only 700 years old. To strengthen the case, the experiment was repeated by another group in Naples. Their findings echoed De Caro's. The shroud's molecular fingerprint did not fit the medieval window. Instead, it aligned with ancient textiles, challenging the radiocarbon results and suggesting that the linen's journey began long before the Middle Ages. For the first time, machine learning and X-ray physics had joined the debate, offering evidence that no medieval forger or modern scientist could easily dismiss. Botanical evidence clings to the shroud's fibers like a silent passport, stamped at every stop along a centuries-old journey. In the 1970s, Swiss botanist Max Frey pressed adhesive tapes against the linen, lifting away hundreds of microscopic pollen grains. Under his microscope in Zurich, Frey identified species native to Jerusalem, Anatolia, and the Mediterranean basin, plants like Gundelia tourneforti, known only to the Levant, and desert halophytes from the Dead Sea Valley. In total, he cataloged 49 distinct species, nearly half of them from the Near East. Critics later challenged Frey's methods and called for modern reanalysis, but the diversity of pollen remains a stubborn fact, suggesting the shroud traveled paths far beyond medieval France. The trail of pollen is not the only record of this global passage. In 2018, the French engineering firm Dassault Systèmes unveiled a new way to encounter the shroud, one that fused technology with tradition. Drawing on high-resolution photographs and computed tomography data, Dassault's team stitched together 1,700 digital slices, building a life-size three-dimensional model of the man in the cloth. The figure, rendered in precise anatomical detail, revealed wounds in proportions that matched historical accounts of crucifixion. The digital body became the centerpiece of a Vatican exhibition, drawing more than 2 million visitors and sparking debate about the ethics of resurrecting sacred images with modern tools. These botanical and digital traces anchor the shroud in both the ancient and the modern world. Each pollen grain and every pixel adds a new layer to its story, a relic that has crossed continents, survived fire and skepticism, and now stands at the intersection of faith, science, and spectacle. Flames tore through the Guarini Chapel in the early hours of April 11, 1997. Smoke billowed against the marble dome as the temperature inside soared past 1,000 degrees Celsius. Fire crews battled the inferno for hours, but the Shroud of Turin, locked inside a bulletproof glass case, remained trapped behind a wall of heat and debris. Orders came down to evacuate. The reliquary, sealed with steel bolts and filled with argon gas, stood just meters from collapse. Amid the chaos, a firefighter named Andrea Seckin refused to retreat, showing remarkable courage. He grabbed a sledgehammer, sprinted up the marble steps, and began smashing at the armored glass. Each blow echoed through the burning chapel, shards flying as the casing finally gave way. Seckin's gloved hands reached through the smoke, dragging the heavy case out in a frantic 90-second dash, just as the roof threatened to cave in. Eyewitnesses later described the heat as unbearable, the air thick with soot and molten lead dripping from the altar. Seekin and his team pulled the Shroud's case out onto the cathedral steps, the linen inside untouched by fire. The rescue became legend almost overnight. Official logs recorded the extraction time, less than 2 minutes from first strike to safety. The bulletproof shell, scorched and cracked, bore silent witness to the risk. For a moment, the Shroud's survival hung on a single act of courage: one man, a hammer, and 90 seconds against disaster. After the flames died down in Turin, the Shroud's future became a matter of policy, not just preservation. Since the 1997 fire, access has been tightly controlled. The Vatican and the Turin Archdiocese, as custodians, have allowed only non-destructive studies. Requests for new samples, especially for radiocarbon dating, have been met with silence or polite refusal. Scientific teams, hoping to resolve lingering questions, are told to work with existing fragments, some barely the width of a thread. The memory of the 1988 sampling, when a single strip was taken from one corner and divided among 3 laboratories, lingers as both precedent and warning. Laboratories around the world have called for broader, more representative testing. Textile experts point to untouched regions of the cloth, areas never exposed to fire or repairs, as essential for any fresh analysis. But each proposal runs into the same barrier: institutional caution. The risk of damaging the Shroud, or of reigniting controversy, outweighs the promise of definitive answers. For now, only imaging, spectroscopy, and X-ray techniques, methods that leave the fabric unchanged, are permitted. The scientific community remains divided. Some researchers defend the medieval date, others argue for an ancient origin, but more than half admit the evidence does not fit any known category. The Shroud's custodians, wary of another public storm, keep the linen behind glass and the debate unresolved. In this standoff, the Shroud is both artifact and enigma, a relic protected from harm, but also protected from the final word of science. Today, the Shroud still resists every forensic tool, from chromatography to machine learning. As technology advances, each answer only deepens the mystery, drawing new generations to its enigma. The limits of science and AI remind us, some questions endure not because we lack data, but because they challenge the very boundaries of what we can know. What do you make of the unexplainable? Share your thoughts below.